Hello, my name is Dr. Steele, and welcome to Steele Mathematics, where lessons in Algebra 1, Geometry, Algebra 2, Pre-Calculus, and Calculus are taught. And today, we are going to talk about multiplying and dividing radicals. Now, what does it actually mean to multiply and divide radicals? When you're multiplying radicals, you're multiplying your coefficients and you're multiplying your radicands. And likewise with division, you divide your coefficients and you divide your radicands. Now let me say this. When you're multiplying or dividing radicals, the radicals must be simplified. And if you can simplify radicals before you actually multiply or divide them, by all means do that. I'll show you what I'm talking about. Let's say we have 4 times the square root of 15 times 3 times the square root of 25. Well, we can take the square root of 25, so we're going to go ahead and do that. So we got 4 times the square root of 15 times 3 times the square root of 25, which is 5. You can't take the square root of 15 or simplify it, so therefore we're going to go ahead and multiply coefficients. We got 4, 3, and 5. You get 60 times the square root of 15. All right, next we have the fourth root of 2n to the fourth times 2 times the fourth root of 24n to the third. Well, if you look at the exponent, we know 4 can go into 4 one time. Therefore, this will be n times the fourth root of 2 times 2 times the fourth root of 24n cubed. And you cannot simplify the square root of 24, so what we're going to do is we're going to multiply our coefficients, which is 2n, and multiply your radicands. That would be 48n cubed. Now, we can simplify the fourth root of 48. Therefore, the fourth root of 48 can be broken down as the fourth root of 16 times the fourth root of 3 times the fourth root of n to the third. The fourth root of 16 is 2, and we have the fourth root of 3 n to the third. And therefore, 2n times 2 is 4n, the fourth root of 3n to the third. And that is your solution. Next, we have negative 5 times the seventh root of negative 16 times the seventh root of positive 15. First, when you take an odd numbered root of a negative, the negative can come outside. Therefore, this becomes the seventh root of 16 times the seventh root of 16. And next, negative times a negative will be positive, and the 7th root of 16 times the 7th root of 16 is the 7th root of 256. Now, I believe we can simplify the 7th root of 256, and this can be broken down as the 7th root of 128 times the 7th root of 2. The 7th root of 128 is 2 times the 7th root of 2, and therefore 5 times 2 is 10. Therefore, your final solution is 10 times the 7th root of 2. So as you can see, sometimes you can simplify before you multiply. Otherwise, you can wait till after multiplication to simplify. Now, let me show you some division examples. Now, let me say this. No radical should be in the denominator. And I'm going to show you what happens if a radical ends up in the denominator. All right, if you look at number 4, well, we can take the square root of 16, which is 4. And next, we look at 2 and 4. 2 goes into 2 one time, and 2 goes into 4 two times. Therefore, your final solution is the square root of 15 over 2. All right, next we have the cube root of 5 over the cube root of 40. And you cannot, really take the cube root of either one of them. However, you can still reduce. 5 goes into 5 one time, and 5 goes into 40 8 times. You can take the cube root of 1, which is 1, and the cube root of 8 is 2. Therefore, the solution is 1 over 2. All right, next we got the square root of 10 over 2 times the square root of 15. Well, we know 5 can go into both 10 and 15. So 5 goes into 10 2 times, and 5 goes into 15 3 times. Therefore, we have the square root of 2 over 2 times the square root of 3. Now, if you remember, I told you we cannot have a radical in the denominator. So therefore, what we're going to do is what we called rationalizing the denominator. And I'm going to write this down. Rationalizing the denominator. Now I'm going to show you how that works. You see the square root of 3. We're going to multiply both your numerator and your denominator by the square root or the radical that is in the denominator. Therefore, the square root of 2 times the square root of 3 is the square root of 6. The square root of 3 times the square root of 3 is 9, the square root of 9, and the square root of 9 is 3. And finally, 2 times 3 is 6. Therefore, the solution is the square root of 6 over 6. So basically, when you're multiplying radicals or dividing radicals, you would multiply your coefficients and your radicands. And with division, you're going to divide your coefficients and your radicands. The radicals must be simplified either before or after you multiply or divide. And we cannot have a radical in the denominator. If you do, you're going to have to rationalize the denominator. I hope that you have a wonderful and blessed day.